Good day to sir. We are from Group 1. Would like to present our project. I'm Jing Xun. I'm going to present company profile. This is our company name, Moonway Engineering Consultant, and beside is the details of our company. This is our organization chart. We have Shakrin, Amru, me, Jing Xun, Shafi, and Winnie.
Good day to Mr. Koh. My name is Winnie Yong and I'm going to present the project background. A pedestrian bridge has been proposed to be constructed over Jalan Kurang for the safety reason of UTHM students and pedestrians. Our company had proposed the design of the pedestrian bridge. Prestress box girder is chosen as the structural system as it is suitable for long-span bridge up to 29 meters. It has lower self-weight and it is cost-effective and it can reduce tension, deflection and cracking under service loads.
Assalamualaikum and hi, my name is Shafi Ahmad Rahman, BFS40302. I would like to present our drawing for the project. So this is the top elevation for the staircase. As we can see here, the total length is 28.9 meters. And this is the side elevation for the staircase.
I'm Jing Xun and I'm continue to present the design specification. This slide shows the specification, action, material properties for concrete and steel that will be used in design the pedestrian bridge. Design and analysis of box girder. This is the flow chart of our design process. First, we input the design specification and design a pre-stress member, determine the ultimate moment resistance and the ultimate shear strength, design the end block, and check the deflection. Catalog of box girder. We will be using the SG1250 series from the Hume Concrete to design our pedestrian bridge. Design of pre-stress member. First, we need to check for the section modulus. Then we compare the section modulus from our design and the section modulus from the manufacturer. Next, we will be find the pre-stressing force by using the Magner diagram. These four inequalities will help us to find the pre-stressing force. After we sub all the values inside to the equation, then we draw the Magner diagram. After that, we can get P pre-stressing force is 5949.27 kilonewton. Our E is 450 millimeter. Number of tendons. We will be using 7 wire super strands with the 15.7 millimeter diameter. The total of 9 nodes and the spacing between the tendon will be 405 millimeter spacing. That's all from me. I'll pass to my other friend.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Muhammad Syagiri Rahman. My metric number is AFY0164. So I will present for the ultimate moment resistance for our project. So based on calculations, I can see that the moment resistance, the value of moment resistance is 99,003 km per meter. So the specification is based on the slide. You can see that the height is 1,250, the base is 250, and also the AC, the value AC uh, I get from the catalog for the box girder, and we and I fill in all the value on the formula, and also I sketch the graph for the strengths, tendon strength curve, uh, and the last the value is for moment resistance is 9,033.
Now I'm going to present the shear design of the pre-stressed box girder. The standard we use is British Standard 8110. The first step is to determine the shear force and the bending moment. Next, the maximum allowable shear stress is checked, which is 3.06 Newton per millimeter square, and it is passed. The third step is to calculate the moment which produce zero stress at extreme tension fiber. And since the design moment is less than the MO, the section is uncracked in flexure. The next step is to calculate the design ultimate shear resistance of a section uncracked in flexure, which is 696 kN. Since the design shear force is between the VC, therefore only nominal links are required. By using 10 mm diameter U-links, the required spacing calculated is 496 mm. Therefore, we decided to use 10 mm diameter links with 450 spacing. This figure shows the shape and the link arrangement for the shear design. Thank you.
So we move on to the end block design. End block design is the post tension beams. The cable are anchored at the ends of the beams. So even in the flash beam and the part of beam where the cable are anchored are often thick to create a rectangular section. So the end block is usually you can see at the end of the beam for the example for the bridge. So we move on to calculations. So the calculations in for the vertical direction is we get the value is 13,178 kilonewton, and for the horizontal is 16,987. So our project is sports career, so there are upper and lower positions. So the value is in the slide. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. My name is Muhammad Nurul Ahmad Kamal. I would like to present about our reflection design. This is our case for the reflection. I will assume that it still reflect about 210 mm from the center, and the formula used in this case is like this. This is formula due to Prestress, and this is formula due to vertical load. For the short-term deflection, it is equal to deflection due to pre-stress plus deflection due to vertical load. At transfer, we got the deflection for the short term is minus 0.002 meter, which is less than span of 250, and the deflection is okay. And for the short term deflection at service, after use of the formula, and we got the resultant short term deflection at transfer is 0.006 meter, which is less than span of 250, and also okay. For the long term deflection, it is equal to deflection long term due to permanent load plus deflection short term due to total load minus deflection short term due to permanent load. Before that, we need to find the time effective. So then we can find this value using the figure 7.1 PS 0 part 2. And then this value will be used to find the LS modulus effective, and for that we need to find this value first by using this formula. Okay. Then for the loading, to find the long-term deflection is the outer loading, which is total load, permanent load, and effective pre-stress force. Then for the deflection for long-term deflection under permanent load is 0.03 meter. For the deflection short-term deflection total service load is 0.044 meter, and short-term deflection under permanent load is 0.018 meter. And then after we got all this, then we got the total long thermal pressure, which is 0.056 meter, which is less than length of 250, which is okay. That's all from me. Thank you.
Now for detailings for the box girder. So as we can see here, we use box girder, and there are 9 number of strands. We are using 15.7 millimeters diameter of 7 wire super strand. There are 9 of them, and they are 402 millimeters apart from each other. For the conclusion, this project is presented the completed design of pedestrian bridge by the Moonway Engineering Consultant. The Prestress concrete box girder system is used in our project. This is because the box girder has some advantages, such as being able to support the larger load and can span up to 250 meters. In our design, the span length of the box girder is 28.9 meters. The size of the box girder was obtained from the manufacturer, which is Hume Concrete near Berhad. The size of 2500 millimeters width and 1250 millimeters depth is chosen based on the span length of the box girder. After that, the design and analysis of the box girder started with the design of the Prestress member. 9 number of strands of 15.7 millimeters of 7 wire super strands were used in our design. From the shaking, R10 for 450 was used. Besides that, the end block also is designed, and 35T40 was proposed. Finally, the deflection has also been checked. That's all.